So in this video, I'm going to talk about exponential equations and exponential inequalities. We've actually done a little bit of this work in the first unit when we were talking about creating common bases and rewriting expressions before we could apply some of our exponent rules. So that's exactly what we're going to do with these problems. It's going to be a little weird because I'm going to do questions 1 and 2, and then I'm going to skip down a little bit and pick up some of the inequalities using this same idea of changing bases. So the very first problem here, I'm going to go ahead and zoom in on this. We have the bases right now are 3, 9, 27, and 81. And I already know 3, 9, 27, and 81 all have a common base of 3. So I know that 3 to the first is equal to 3. I know that 3 squared is equal to 9. I know that 3 to the third is equal to 27. Now, one of the things I want to be careful about is this fraction is 1 over 81. Now, it might have been a while since you have done some exponent rules, but here's what I want you to know. 1 over 81 is the same thing as 1 over 3 to the fourth. All right, 3 to the fourth is 81. The other way to write this so that you don't have a fraction, it's nice to not have the fraction, is you can actually rewrite this as 3 to the negative fourth power. The power of negative 4 means you actually create a fraction, not that the number becomes negative itself. And so if you haven't done your exponent rules in a little while, this is what I'm going to be using. All right, so 3 is going to stay 3. 9 is going to get replaced with 3 squared. 27 is going to get replaced with 3 cubed. And 1 over 81 is going to get replaced with 3 to the negative fourth. And there's an x minus 4 here. All right. So now I am going to take these powers that I have here. My exponent rule says I have a power raised to a power, so I can multiply those together. So it's going to be 3 to the third times 3 to the 2x minus 4 times 3 to the 3x minus 9. I lost apparently an equal sign when I was writing the last line. This is an equal to here. Wow. Okay, so give me 1 second. I'm going to do a little, maybe a little shift here. Nope, not what I was going to try and do. So let me delete that. Slide that on over. Put an equal sign where it's supposed to go. All right. So try this again. Let's see, 3 to the negative 4x plus 16. All right. We have a base 3, and a base 3, which is what we need because now the exponent rule says I can add these together. Okay. So base 3. Looking for some like terms here, I've got 2x and 3x, so if I combine those, that's 5x. 3 minus 4 minus 9 is going to be negative 10 equals 3 to the negative 4x plus 16. Okay, we have the same base on both sides, raised to some power. And the only way this equality works is if this exponent is equal to that exponent. So that's what we're going to do next. So 5x minus 10 is equal to negative, let's see, 4x. That's a horrible x. Hold on a second. 4x plus 16. Okay, I'm going to add 4x to both sides. I am going to add 10 to both sides. So 9x equals 26, which makes x equal to 26 over 9. You could, if you are decent with your calculator, you can actually test it back here. All right. I'm actually going to split screen. Let me show you how to do that in case you haven't done it before. Let me pop up Calculate 84. It's not that difficult to do, and it's nice to be able to test your work. But again, it depends on what you understand your calculator can do. I'm going to store this value as x. So 26 over 9. Now how do you store? Just hit the STO. That will store, and I'm going to assign this to x, okay, and hit enter. So 2.8 repeating is what the value is. Now, using my calculator, I am going to put in this original function here. So 3 to the third, parentheses, oops, hold on a second. Get out of there. Okay. So 9 raised to the x minus 2. And the calculator, anywhere that sees that x, will use the value that we have just stored. So x minus 3. Now this is the weird one. When I said test, I really am going to test this. So I am going to use the test functions here. So second math, and the very first test is equality. And I'm just going to put in the rest of this equation. So 1 over 81 raised to the x minus 4. Now this took me years to figure out when you do this test, you are going to get back one of two answers. You are either going to get back a 1 or you're going to get back a 0. And it took me years to remember which one was which. It's a binary system. 1 is affirmative, meaning it's a good answer. 0 means something went wrong. So when I hit enter and I get the value back of 1, what that just tells me is my calculator took this value for x and tested it that this left side is equal to this right side. Do you have to do that? Absolutely not. Not for these problems. Is it nice to be able to do it? Yeah, because it tells me that I have the right answer here for number 1. So for the other problems, I'm not going to test them, but you could, just so you know what that looks like. All right, so problem number 1 is done. I'm going to go ahead and slide on over to number 2. I need some common bases here. I have 6, 36, 216, and 1,296. In order to be able to solve these problems right now, you have to be able to make a common base. We're not going to do trick questions, or if we do, you might see it on a homework assignment where it's literally a typo on my fault. Okay? So things I know. I know 6 to the first is 6. I know 6 squared is 36. I know 6 to the third is 216, and 6 to the fourth is 1,296. Feel free to play around with your calculator. What I would recommend is whatever your smallest base is currently, out of everything that you're given, try that one first. Okay? So let's do some replacement here. 6 is not going to get replaced. 36 is. 216 is. Let's see, that would be 6 to the 4th to the 12th. Okay. So I'm going to do a little multiplication, and multiplication here, here, and here. So 6 to the 8x times 6 to the 2x over 6 to the 3x equals 6 to the, what is that, 48? Yeah, sounds good. Okay. All right. 3 things are happening with this problem on the right. No, that's the left, on the left side. We've got 2 things in the numerator that are being multiplied together. So I'm going to be able to add those exponents. And separately, I'm dividing by the same base, so I get to subtract that exponent. So 8x plus 2x is 10x. 10x minus 3x turns this whole left side into 6 to the 7x. So we now have like bases. The only way for those bases to be equal to each other now is if the exponents are equal to each other. So divide both sides by 7, and I will get the nice handy-dandy answer of x is equal to 48 over 7. Again, you could check this using that same method of testing. I already have. I know that's the right answer. And again, unless the directions say otherwise, leave your answers as exact. So as goofy as 48 over 7 is, it's perfectly happy as an exact answer. All right, so 1 and 2 are 2 equations. I'm actually going to skip over 3, 4. I'm going to bounce down to some inequalities. and work with some inequalities using that same methodology so that you understand what's going on there. The ones that I skipped over, I'll make a separate video because those are slightly different. All right, we have 2 to the x is greater than or equal to 16 root 2. I need a common base. And this is going to be a little weird, but you actually have 3 pieces to deal with. You have 2 to the first, which is just 2. You have 2 to the fourth, which is the 16. And the square root of 2 is 2 to the 1/2 power. Again, I don't know how often you've done your exponent rules recently. The reason this works is because a root 2, in this case is a square root, has an index of 2 that we just never write, and it has a power of 1 that, again, we never write, but it's there. So the fractional exponent becomes the power of 1 divided by the index of 2, or just 1/2. So a little bit of replacement here. So we've got 2 to the x greater than or equal to 2 to the fourth times 2 to the 1/2. So I don't have any extra like multiplying exponents together. I am, however, multiplying 2 bases together, and I want to combine their powers. And the way I'm going to do that is by adding them together. So 4 plus 1/2 is 9/2. Okay. Now, in the same way that we were able to say, okay, the bases match, so now that all that matters is the exponents, that's the same thing here. X is greater than or equal to 9/2. So if I look at my number line, the only critical value I have here is 9/2, and it says x is greater than that. So I'm going to shade to the right, and I need to use a bracket here. So I'm going to go from 9, that is a horrible 9, try that again. 9 over 2 to infinity is the interval that makes that inequality true. Okay, I'm going to do one more here in this video. That's going to be problem number 8. So I've got 1/3 to the x is greater than or equal to 9 root 3. So in this case, I'm definitely dealing with a base of 3. Okay, so 1/3 is going to equal 3 to the -1 power. 9 is going to equal 3 squared, and root 3 is going to equal 3 to the 1/2. So those are the replacements I'm going to use for this problem. So let's see, 3 to the -1 raised to the x greater than or equal to 3 squared times 3 to the 1/2. Little multiplication up here, -1 times x. So 3 to the -x is greater than or equal to 3 to the, I'm going to go ahead and add these two exponents together. So 2 plus 1/2 is, what is that, 5/2? Okay. At this point, we have one base on the left, one base on the right, so I can go ahead and make the inequality from just the exponents. So -x is greater than or equal to 5/2. Not a huge fan of having the x be negative, so I'm going to go ahead and divide both sides by -1, but because I'm dividing by a negative, the inequality, I'm about to say it needs to flip, but then I'll actually flip it. The inequality symbol needs to flip to deal with the negative, so -5/2. On a number line, let's go ahead and pop a number line up in here. The only critical value is -5/2. And it says x is less than -5/2, so less than is going to be to the left here. Bracket, because we have the equal to component. So this is going to be from -infinity to -5/2 with a bracket. Okay, so I hope this has helped clarify a few things in terms of how to deal with inequalities and equations where you need to do base changes. There will be a secondary video, like I said, that will deal with, and actually problems like number 10 would be an example, but I'll go ahead and deal with some of those other problems on the page that I skipped over earlier. As always, send me any questions or concerns about the material or anything you need me to clarify.